1.
All right, so we're going to take review and build a graph. That's what we're doing with quadratics, which is what we've been doing for a week here. Or not quite a week. All right, so let's start with, we'll just start with number, I'm going to start with 17 since it doesn't have a fraction in it. I'm going to start with that one. Y equals -2, parentheses, x plus 1 squared minus 5. Okay. Now, the things that I want to find about this are axis of symmetry, vertex. I got to know which way it's going to open, up or down. That tells me maximum or minimum, all of that stuff. The focus, the directrix, the X-Intercepts, and all that stuff. So if I'm going to find X-Intercepts, then I can either do this by square roots or I can do by standard form and then quadratic formula. So I'm going to kind of review everything we've done. So that's in vertex form. If I want it in standard form, because either I'd rather do quadratic formula to find my X-Intercepts, or just because I'm more comfortable with standard form, that's fine. So let's go over how to get it there. So to get this into standard form, we got to remember that x plus 1 squared just means x plus 1 times x plus 1. And then when we multiply those two together, that's x squared plus x plus 1. X times x is x squared. X times 1 is 1x. 1 times x is 1x. 1 times 1 is 1. That's where it's distributed property twice. Really all it is. Yes. And then I can either simplify the parentheses or distribute. I'm going to simplify it first and get x squared plus 2x plus 1. And some of you, may be quicker at multiplying those two together. You can do it in your head that quickly. There is a shortcut to it that's always square the front, square the back, multiply them together and double it in the middle. So x squared is x squared, 1 squared is 1. 1 times x is 1x times 2 is 2x. That's the shortcut to it, but it is the distributed property. Okay. And then I'm going to distribute the -2 to all of that. So that'd be -2x squared minus 4x minus 2, and then minus 5 that was already out there. And that's going to get us in standard form, -2x squared minus 4x minus 7. Okay. So this is vertex form. This is standard form. That's the very first thing we did. That's what we did the first day, I think Thursday of last week. Okay. Vertex form to standard form. All right. The next thing that I want to do is start building these pieces out of this thing. And the axis of symmetry is what I'm going to start with. The axis of symmetry, if you're in vertex form, it's x equals h. And h in this problem is -1. Okay. If you go from the vertex form. If you're going from standard form, the formula is x equals -b over 2a. So I would have 4 over 2 times -2, which is still -1. It's the same answer. Okay, so there's a check that you can do there if you're working with vertex form and standard form. You can check yourself to make sure you did it correctly.
It's really easier to get all that out of vertex form.
Absolutely. Absolutely. If it's in vertex form to start with, it really is easier to get all of those things out of it to start with.
So we just need to know really how to get it into vertex form from standard.
That would be helpful for that. Absolutely. That's the reason we went over doing that. That's why we did that. So that you could convert it if you wanted to.
Yeah, let's do it from standard to vertex.
And then vertex, yeah, we'll do one of those in a second. So the vertex then would be at -1, and then up here in vertex form, -5 is the y value, or the k for that. In standard form, we've got to plug in this -1 here and work it out. So that'd be -2 plus 4 is 2 minus 7 is -5. Still the same answer by plugging in the x value of the vertex into the problem. Does the same thing in vertex form. If you plug in a -1 there, it would end up doing the same thing. Okay. All right. So there's our vertex. We need to know, is that a maximum or a minimum? It's a maximum. Why? What's A? It's -2, so it's less than 0, right? Yeah, -2. So it's a maximum. A is in the front there. Now right there. If it's negative, it's going to open down like this. So it's got a highest point. That's a maximum. That highest point is at that vertex. Okay. Next thing we want to know is the focus and the directrix. Let's go ahead and get those. Focus, -1, and then you take the -5 and you add 1 over 4 times A. So -5 plus 1 over parentheses 4 times -2. Math, enter. -41 over 8. The x value of the vertex was. The y value is what we're adding and subtracting to.
I know, but
A is what's in front of the whole problem. That's what decides max or min. How much was that again? 41 over 8. -41 over 8. So we're going to write it in fraction form, but when we go to plot this on the coordinate plane, we're going to think, okay, what's -41 over 8? It's a little bit more than -5. We can kind of estimate where that's at. Okay. The directrix. Y equals -5 minus 1 over 4 times A. -5 minus 1 over 4 times -2. Or if you just typed in a -8 there, that's fine. Enter. Math. Enter. -39 over 8, yeah. Remember that, and when we draw this, I'm going to show you what we're finding there. Okay, the next thing we want to find are our intercepts, and the way we need to think about those is there's a y-intercept, and then there's x-intercepts that could happen. Okay, so this is where the two different forms can come in handy. I've got it in standard form. What intercept is easy to find from standard form? The y-intercept. What's the y-intercept? -7. Okay. 0, -7. Plug a 0 in for x. 0 times -2, 0. 4 times 0, 0. 0 minus 7 is -7. That's the y-intercept. From standard form, it's always going to be c, whatever c is. From vertex form, you can plug in a 0 for x and work it out, and it's still going to get you the same answer. Okay. All right. X-intercepts. Well, when we go to find x-intercepts, we need to know something about the problem. We need to know, does it even have x-intercepts? And that's where the discriminant comes into play. Which, if we're going to do the discriminant, what do we need to have? What form do we need to be in? No, the discriminant. I mean the discriminant, b squared minus 4ac. I need it in standard form for that. So -4 squared minus 4 times negative 2 times 7. That's going to be 16. That is negative 7. Yes, thank you. Minus 14 times 4 would be 40 and 16. Minus 56, which is negative 40. What do we know about our X-intercepts? There are no X-intercepts because the discriminant is a negative number. It's on this handout. It tells you that. Okay, you got to know that, and it's all based on the discriminant being a negative number. Yes, ma'am. No, you got to know this stuff. Huh? We will have we'll probably have a quiz tomorrow. No,
That's just wrong.
you got to know it.
Do they not give us these equations?
No.
EOC, then
No.
what do they give us?
Nothing.
A book and problems today.
Well, yeah, I get that, but they end up.
They don't give you all of these. No, they give you the quadratic formula. That's it. On the ACT, they give you none of that.
Okay, I know the quadratic formula.
Okay, then you know the discriminant then.
Yeah, I mean,
All right, so once you find that, what we want to do is get a better picture of what the graph's doing. So we need to build a table. Look there under the graph thing, it says create a table of values centered around the vertex. So here's our table that we're going to build, and then we're going to go to the graph paper. Centered around the vertex. So in the table that you make, the vertex goes in the middle. And then I want you to pick 2 ordered pairs that are to the left of -1 and get 2 ordered pairs that are to the right of -1. If you had X-intercepts, they would be 2 of those. One would be to the left, one would be to the right. We don't have X-intercepts, so we're going to have to use -2 and -3, 0, and 1. Hey, we happen to already know one of the ordered pairs where X is 0. What's the Y value when X is 0? -7. We already found that. That would happen to be our Y-intercept. So we only have to really work out 3 X values. We do have a nice graphing calculator that can help us work those out. So I'm going to go to my calculator and get a little help here.
well, why don't we just make it a pattern?
It is a pattern.
2, -3, and then -3, -1, and then 1, -9. Is that right?
How?
Because -1 and -5 is an ordered pair, and 0 and -7. So you're just going adding 2 as you go down, and you're
That's not how it works.
subtracting 2.
No, that's not how. If it was linear, that would probably how it works. And that's not necessarily how it's going to work here because it's quadratic. Kylie. Y equals. The Y equals meaning I'm going to type in that original problem, -2, parentheses, X plus 1
We gotta be able to use that.
squared. You don't have to. You can plug them in by hand if you want to.
How do you get there?
Y equals.
With that?
Top left. Top left. Left.
I'm at the top left.
No, you're not. Top left up there by the screen.
Right here?
Yeah.
It don't say Y equals on it. It don't even say anything. It's wore out.
Okay. But it's the top left button. Okay. Now, once you got that typed in there, you're going to hit second and then graph to get to this table.
Hit alpha.
No, X. To type that equation in, you type in -2 parentheses. The X is right there beside alpha, right there. Same place it's been.
I never knew it was there.
Once you get that typed in, you're hitting second and graph to go to the table. And then you're going to plug in the table that you've got already handwritten. So we're going, the X values that we're going to type in are -3, -2, -1, 0, and 1. -3, enter. -2, enter. -1, enter. 0, +1.
Hers is on, like, for a while, one is on the greater than sign. How does she change it to?
Now you got an app running. You shouldn't be able to.
Something running here. Wrong. Mine got this one.
Mine gave me a equation.
Mine gave me
Clear
this.
out.
Not equations, but like.
Clear.
No, I'm sorry.
You hear what I heard? You hear what I heard?
Mine won't do that thing, the square root, not square root, square root.
I don't know what's going on here. Oh, you can drop your own way.
Oh.
Now when you type in.
Yes, I need help. Everything.
Yeah, those are just some that somebody's typing in
I
there.
got it in
You just take the ones that were, rest of them are, it's calculating, it's not necessarily something you have to have.
I don't know what this shit hurt.
So, second.
Mine is in the anchor, it's like a tape measure. And I was like,
That will let you,
oh, that's not the one you take seven.
Yeah.
now.
I'm like,
Anybody else not able to type them in?
I got something going on here.
I don't know how many they don't equal the same. I mean, it's the problem is it's that same way that they
That way it's all calculated. Anybody else is not letting you type in the X values you want? Now. It should stay that way from here on out.
Are those the answers up there?
Those should be the answers if you typed in the equation correctly.
Because I typed in the equation.
Did you type it in correctly?
Yeah, like I'm looking at it on my paper. and it's
Right now.
I'm looking at it on my screen and that's all.
Yeah.
Is it exactly that?
the same to that. And
That's all.
you can look at it. So you can-
It's not that. It's a minus sign. If anything is different, it's going to calculate it differently. All right, so we get those values out of that table. And yes, it is a pattern, but it's not necessarily that pattern that you were saying. It is a pattern because it's an equation. It's always doing the same thing to the X value, but it's not the pattern that you were saying there. All right, so -13
There's so much work in one problem.
can be, yeah. All right, so those are our ordered pairs that we're going to use when we go to graph this, okay? So let's go to graph. I'm going to pull up another note here and change it to graph paper so that we can pull that out. Okay. All right. So we're going to graph that. We need a coordinate plane. I know this one is going to have a lot of negative y values, so I'm going to draw it so that I got plenty of room in the negative direction, hopefully. But yeah, I'm going to make more room in the negative direction. So there's my coordinate plane. This is number 17. Okay. So I'm going to plot those points. I'm gonna plot the -1, -5. That's my vertex. And then I'm gonna plot the -2, -7, -3, -13. And the other side, 0, -7. Yes.
So this thing is like what we talked about yesterday, the dish thing.
Yeah, it's kind of like the parabolic dish. And then this is the shape the graph makes. But we got to put all that other stuff on here. We need to draw our axis of symmetry. That's not very difficult. It's just a dotted line that goes straight down through the vertex.
Bless you, bless you.
Bless you.
Thank you.
That's the axis of symmetry. The directrix is the horizontal line at that number that we found. So the directrix, what was its equation? Y equals -39/8. What was that as a decimal?
Like a little over 5, wasn't it?
Not quite 5.
A little under 5.
A little under 5. So at -4.8 or something like that's where it was at. So I'm going to go to my graph, and at -4.8, which would be about right there, I'm going to draw a horizontal line because that's what a directrix is going to be, a horizontal line. Yeah, in that. Okay, so we got a horizontal line. That's a directrix. The directrix should be outside of the parabola. Should always be on the outside of it. If it ever goes through it, then something's not in the right spot. Okay. Now we need the focus. That's the only other point that needs to be on here. Is the focus, and it was at
-41/8.
which was a little bit more than the -5. That's where that was, and that's about right there. So the directrix is that dot right there, or I mean the focus.
Just put a dot there.
Focus, yeah, just put a dot. Yeah, I'm just pointing it to it, saying the focus is there. I'm telling you that this is the directrix. When you do this, for me on a quiz, you're not going to point to them and tell me that's what they are. Hopefully, you could if you needed to. Yeah. Well, you got to know what they are if you're going to get it right. Axis of symmetry. Okay. So we found all of that stuff, and then we drew a graph with it. Okay. So we plotted 5 points on the graph. 1, 2, 3, 4, 5. And then we plotted the focus. We drew the axis of symmetry and the directrix. That's what I want to see on a graph of these. But you got to be able to find all of that stuff first. It's on the same line. It's the X value is the same. The Y value is a little bit to the inside of the parabola. It's hard. This one's real close to the vertex, but it's not exactly the same. It was 1/8 of an inch further, I guess. Okay. All right, let's look at let's go back and do all that stuff for number 13. Okay. That's in vertex form. So that should help us out here, because that should get us the axis of symmetry, the vertex. And is this vertex going to be a maximum or a minimum? We can tell that already. Minimum. So this one's going to open up. Okay. And axis of symmetry would be x equals what? -1.
Are we doing this one just for an example thing?
Yeah, doing it as another
Alright,
example.
what
Yeah.
about, can we do one that shows us how to get it from standard into?
Yeah, we will. We're going to do one of those next. We gotta do
I know
two
how
of
to do
each.
it this
Yeah.
way right here.
Yeah. All right. The vertex would be at -1, -1, and y'all said it was a minimum. So we know that the parabola opens up because that's a positive number in front of the parentheses. Okay. So with the focus, -1, and then we're taking the y value and adding 1/4 times 1/8. 4 times 1/8 would be 1/2, right?
Yeah.
So second quit. So -1 plus, I'm going to put 1 divided by parentheses 1/2. +1.
So your focus is -1.
So this one, when we draw, it'll be a little easier to see the difference in the vertex and the focus because it's a little further apart. Okay. Directrix is the next thing. So -1 -2 would be -3.
How do I get out of this?
Second, and then the mode button right there beside it.
Clear after.
Did y'all get 3 for the directives? -1 minus 1/1/2. Should be -3. And now we need our intercepts. Now I've got it in vertex form, so finding my y-intercept can be done from this form by doing what? Plugging in what for x? 0. 1/8 times 1 minus 1 would be -7/8. 0, -7/8. That's one of our intercepts. Now, X-Intercepts, it's not in standard form, so I can't check the discriminant unless I put it in standard form. Okay, so if you want to put it in standard form, you can, or you could just solve it and see what happens. Add 1. Get 1 equals 1/8 x plus 1 squared. Multiply by the reciprocal, 8. 8 equals x plus 1 squared. Now I can do what? Take the square roots, plus or minus on the side with the 8. So x plus 1 is equal to plus or minus the square root of 8. But 8, that simplifies to be 2 radical 2, right? Track 1. So we get x-intercepts of x equals -1 plus 2 radical 2. X equals -1 minus 2 radical 2. Okay? This is where we did the decimal approximation stuff. Okay? Decimal approximation stuff on that. So we need -1 plus 2 square root of 2 positive 1.83, a little less than 2, and then -1 minus 2 square root of 2, -3.83. Oops, wrong button. All right. So our x-intercepts are at 1.83, 0, and -3.83, 0. We had 2 x-intercepts. Now we could have taken that vertex form and put it in standard form and done the discriminant, we'd have ended up with the same situation. We'd have had a positive number underneath the square root of the quadratic formula, which means you have two x-intercepts. We just found them with square roots here, solving that vertex form. Okay. Now, next thing we need to do is our table. The good thing is we've got a y-intercept and we've got two x-intercepts. How many points is that? 3. We also have a vertex. That's the 4th point. Remember, we're centering it around the vertex, -1, -1. And then we have 0, -7/8. And then we have a number that's bigger than 0, 1.83, 0. And then I got, that's the y-intercept. Because I'm just picking x values that are, the vertex is here in the middle. That's the -1, -1. So I'll go up to the right of -1 would be 0. And I've already found that one. So that I knew that the answer was -7/8. And then I knew that 1.83, one of my x-intercepts, was to the right of 0. So I'm going to use it.
I thought that y was -3.
That's your directrix. That's not your y-intercept. It's your directrix. So we need to get something at -2. So if I plug in -2 into that equation, that would be -1 squared is 1, 1/8 minus 1, be -7/8. Notice it's the pattern. It's just not that normal pattern out of that. So we've got our ordered pairs. And I can graph that. This is number 13. I don't need a really big quadratic or coordinate plane here to get this quadratic on there because everything's kind of close to the origin. And plot those points, -1, -1's right there. 0, 7/8, or 0, -7/8, be about right there. -2, -7/8, be about right there. 1.83, about there. -3.83 is about there. My axis of symmetry, just a dotted line straight through the vertex. Every time it will be that. The parabola is kind of wide on this one. It still does that same shape. It's always going to have that U kind of shape to it. Okay. I got my axis of symmetry. I need my focus and my directrix. My directrix was at -3. Should be right there. My focus was at -1, +1. Just that point right there. Just making it a large point so we make sure we see it. And that's the graph of that quadratic. It's a lot of stuff, but it's what we got to know. I mean, there's going to be questions about all of those different things on the end of the course. I mean, it is what it is. All right, let's look at a couple of these standard form ones. 24 is where we start. I'm going to go to regular paper and get all that information done. For 24, we've got y equals x squared plus 5x. Okay. And One of Kegel's concerns was being able to convert that over to vertex form, because it seems like vertex form makes it a lot easier to get some of the stuff. Standard form is good for the Y-intercept. It's actually good for the X-intercepts as well, especially on this one. But vertex form is really good for axis of symmetry, vertex, focus, directrix. It gets about 4 of them there that makes it easier if it's in vertex form. So let's put it in vertex form. To do that, what's added? What's out here? What's the C from standard form for this one? 0. There's nothing there. Sometimes it helps you guys if we put a 0 there. If it's not, if there's nothing there, you put a +0. It'll help you kind of keep things consistent with all the problems where there is something there. Okay. Then to complete the square, what do we need to do? Yeah, take half of 5 and square it. Half of 5 would be 5/2. Squared would be 25/4. That's going to give us x plus 5/2 squared minus 25/4. And there we have it in vertex form now. And remember, it's always going to factor as x plus whatever half of b was. That's half.
Where'd you get 5/2?
Half from where you told me to. Take half of 5. 5/2 is half of 5.
So that's like 25/4 disappears.
This 25/4 here is hidden inside of this, because what we're doing is we're factoring this trinomial to be that into a perfect square trinomial. That's what we're turning that into. Now, from there, you've got both forms to work with, so you can go with whichever direction you want to get those pieces. So you get your axis of symmetry, be x equals -5/2, vertex -5/2, -25/4. Is that a maximum or a minimum? Try again. Had to be a minimum, because what's a in this problem? +1. That means this thing opens up. It's a minimum. Okay. So once we found the vertex, we want to find the focus. -5/2. And then we got to do -25/4 plus 1/4 times 1. Well, that works out pretty nice, because that's -24/4, which is just -6. That's a good ordered pair. A little better than the -25/4. And get our directrix. -25/4 minus 1/4 be -26/4, which reduces to -13/2. From there, we need our intercepts. The Y-intercept would be zero, right? And then our X-intercepts, I'm going to go back to the standard form and get my X-intercepts, because I can factor that. X equals 0, and then x equals -5. We already got 0, 0, and then 0, -5. So happens that one of our X-intercepts is the same as our Y-intercept, because it was at the origin, and that's the only place that X and Y are the same, intercept-wise. So we get our intercepts, and then we just need to build a table, X and Y value. So I'm going to put the vertex in the middle, -5/2, -25/4, and then -5/2, how much is that as a decimal? Negative 2.5, right? So to the left of negative 2.5 would be negative 3 and negative 4. To the right of that would be negative 2 and negative 1. That could get us those. That good? All right. So I just need to get those values, the y values that go with those ordered pairs. Okay. Negative 5, 0. Yes, thank you. Get in a hurry. Give you time to work today. So I'm going to go to the table on my graphing calculator, go to y equals, type in the equation, x squared plus 5x. 5x. Then I'm going to go to the table, and I'm just going to type in that table. Negative 4, negative 3, negative 5 over 2, negative 2, negative 1. I get my ordered pairs that go with that. Okay. Negative 6, negative 4, negative 4, negative 6. Those are what I want to go and graph on the coordinate plane over here. There. All right, what do you need? Okay, all right. The ordered pairs, yeah. All right, so they're all negative y values and negative x values, so I'm just going to make sure I got room in that direction.
How do you know
I go off of the vertex. The vertex is in the middle, and I just think, okay, what's to the left of it? And negative 2.5, left of it would be negative 3 and negative 4. And so I just go immediate, just right beside it. And then to the right of negative 2.5 would be negative 2 and negative 1. So I'm plotting those points. Negative 4, negative 6, negative 3, negative 4, negative 2.5, 25 over 4 was negative, what was that? Did I get that right? I swapped those X's and Y's, those Y's there. Those should be negative 4 and negative 6, negative 6 and negative 4. Dyslexia kicked in there. That should make it turn the right way. And then negative 2.5. 25 over 4 is negative, negative 6.25. About right there. And then at that point. Yes, yeah. Thinking about it as a decimal there to plot it on the graph. 25 over 4 would be negative 6 1/4, negative 6.25. And then I'm going to plot my intercepts as well, because that's going to help me get the graph to look better. My intercepts were at negative 5 and 0, so that's going to help me get my graph to even look better.
With what?
So I plotted all of these, and then this seems to have been a problem here lately. Some smart aleck is trying to hijack people's Chromecast. If he gets caught, I can't do that. But I can make him wish he didn't do it. I don't know. It could be anywhere in the building.
Is it like two of them?
Yeah, I've heard. Yeah. All right, so we're plotting all these points, and then these 2 points right here were the intercepts that I found. X-intercepts that I found, and technically that's a Y-intercept as well. Okay. So that makes my graph just look better. The more points I have, the better. 5 usually gets you a good picture of it, but here we got 7, makes it even better.
So we do point the intercepts.
There's intercepts. If you've got them, plot them, because that's going to help your graph look better. It's also going to show, hey, I know that this crosses the x-axis here. It's also a good. And then we want to draw the axis of symmetry. Dotted line right through the vertex. Should always be that. And then directrix, where was it? It was at y equals negative 13 over 2, which was what? That'd be negative 6.5. Yeah, you should know that. Which is about right there. And draw my line too straight, but freehands would not be bad. And then the focus was at what point? Negative 5 over 2, negative 6. So right there.
Negative 5 over 2 over negative 13 over 2.
The directrix is going to be y equals negative 13 over 2, which is this horizontal line at negative 6.5, which is what negative 13 over 2 is. And there we get our graph of a parabola from standard form. You can check it, hit graph on your calculator. Yeah, that was 24.
Can we, on our homework, can we just use this paper?
What do you mean? The one that where I've already worked? Sure.
Instead of having to redo them graphs all over
Sure.
again.
Sure, that's fine. That is fine. All right, so that's what the graph looks like on the calculator. That's what it looks like on my paper with the axis of symmetry and the directrix and all on that. Okay. All right. Let's do 26, and then it'll be time to go home. Y equals negative 3x squared minus x minus 8. It's in standard form, not exactly in the best of forms there because, I got a negative 1 in front of x. But, if I want to put that in vertex form, I can. It's not going to be as easy for this one. But I'm going to have to factor out a negative 3 out of these front pieces. And you're gonna flip out here. Because if you divide negative 1 by negative 3, it's positive 1/3 that happens there. So you end up with fractions involved. So this is one of the drawbacks of putting it in vertex form. As I know it's late in the afternoon and you're tired, but I'm tired too, and I'm trying to help you. So please wake up. Kegel, can you please wake up? Please? No, you weren't. You better be. All right. So we're going to take half of 1/3. Half of 1/3 would be 1/6. We're going to square it. So I'm adding 1 over 36 on the inside. So I'm subtracting negative 3 times 1 over 36 on the outside. Because I've got the negative 3 out here. So really, I'm not just adding 1 over 36. I'm adding negative 3 times that. Because it's out here in the front. So I have to subtract that out here. Yeah, because that's a negative 3 there. That'd be x plus 1/6 squared. And then we just need to work this out. So that'd be negative 8 plus 1/12. Should be.
I got negative 15 up too, but I don't know if it's put it in the calculator.
I don't think so. Negative 8 plus 1 over 12. Yeah, maybe. No. 95 over 12. Negative 95 over 12. So that vertex form, not real pretty. Now, here's the thing you got to remember, guys, is that if it's in standard form, you can get the axis of symmetry and the vertex without doing all that stuff. By using that little formula that's on your thing there that we talked about yesterday, negative b over 2a, and then plugging that in. You know, so your axis, x equals negative 1/6. You know, you get that. If you want to use the formula, that'd be positive 1 over 2 times negative 3, which is negative 1/6. That's negative b over 2a. That's going to work to get you the x value of your vertex and your axis of symmetry. Since we've got it in vertex form, I can do that. If I want to get that y value otherwise, I can take this negative 1/6 and plug it into this original problem and work it out. It's going to get me that same number. If it doesn't, something went wrong. Okay. So there's our axis of symmetry. Is that vertex a maximum or a minimum? Max, because it's a negative a value.
So max is negative.
Negative is a max, positive is a min. Because a negative is going to make the parabola open down, like this. A positive is going to make the parabola open up, like that. Okay. That number right there, that's
Because of
the negative makes all the values go down. Like negative makes it less, right? So that negative in front of the x squared has the x squared is the most powerful part of that quadratic. If it's got a negative on it, it's going to have the most pull, and it's going to pull them down. So that's why it points down with its negative. And then that creates a highest point. That's the maximum. And then if it's got a positive in front of it, that's on the x squared. It's the most powerful. So it's going to pull all the points up. And that creates the lowest point. That's the minimum. That's what's happening there. All right. Now, focus. Negative 1/6. And then I need to take negative 95 over 12 plus 1 over 4 times negative 3, which would be negative 1/12. And so that'd be negative 96 over 12, which is negative 8. That's nice. And then our directrix. Negative 95 over 12 minus. Yes, ma'am. Okay. And that's going to be negative 94 over 12, which reduces, right? Negative 47 over 6. Intercepts. Y-intercept would be at 0, negative 8. Get that from the standard form. It's C. Always going to be that way. X-intercepts. You could try to factor it, or you could, it's in standard form. I'm gonna look at the discriminant there. So that'd be negative 1 squared minus 4 times negative 3 times negative 8. Be 1. 24 times 4 is 80, 96. 1 minus 96. Negative 95. So what's that tell us about x-intercepts? None. No x-ints. Okay, so we know this thing is not going to cross the x-axis because it has a negative discriminant. Should already know that from the work that we've done already. And then, so we need to build a table around the vertex. Vertex is at negative 1/6, negative 95 over 12. I'm going to, to the left of negative 1/6 be negative 1, negative 2. To To the right will be 0 and 1. Okay, since this is a fraction in our vertex, it's probably not going to be that nice pattern on the coordinates like what we've had. But the good thing is I got the graphing calculators and get me those values just like I want them. Okay, so just need to go to y equals, type in the equation, negative 3x squared minus x minus 8. Go to the table, and I'm going to type in those values. I got negative 2, negative 1, negative 1/6. That's going to help. I'm getting the decimal approximations out of that. It's what it's cranking out for me. And then 0 and 1. Okay. Notice it's not that nice pattern like it's been being where you got the same two numbers on top as you do on the bottom. That's because the vertex was a fraction. That's the reason that happens. Okay. Now, plot those points. That's all we got to do. Negative 18, negative 10. Negative 8. And negative 12. All right. Because we're doing the entire thing. That's the thing, that you should have all of everything except for the table done already.
So we're going to have to do every bit of it on the quiz.
Now I'm going to ask you for one part of different problems.
Okay.
Is what I'm going to do. All right, so I'm plotting those points. I don't know. Hear you guys talk. It's not.
Oh, I need to do the whole thing.
Make sure I got a lot of negative y value space there. 0, negative 8. And 1, negative 12. And then negative 1/6. And then 95. What was negative 95 over 12? It's negative 7.9. About right there. And then negative 1, negative 10. And then negative 2, negative 18. 12, 14, 16, 18. Dotted line for the axis of symmetry. And then focus was at negative 1/6, negative 8. And the directrix was at almost negative 8. Right there. And the directrix is right just shy of the vertex. Oops. The ruler. Okay. So there's the graph. Number 26.